Good morning. First, I want to thank the conference organizers for giving me the chance to speak to you all today. I'm delighted to be here at LAK 2013. It's great to meet so many people who are focused on the opportunities and challenges of working with this next generation of educational data. These are exciting times, as the Vice Rector mentioned and all of us experience. We are in a situation with data sets of unprecedented richness and scope. There are new technologies and tools that are widely adopted, and we have here a dedicated community of researchers working to focus on how to best use these. My research for many years has focused on the question of how students learn, seeking to reveal and explain the fundamental mechanisms underlying student learning. In the last several years, I've applied this theory to improve teaching and learning in real-world contexts and to develop methods for extracting meaning from educational data. As you well know, there are many metrics and measures, statistics and results we can derive from these data sets. Many of these relate to performance and behavioral measures. I'd like to argue that we can't lose sight of what we're looking to do with these data, that is to understand how well our students are learning. But students' learning state at any point in time is a latent variable. We must infer it from the complex and subtle patterns in the performance and behavioral data. So this raises the fundamental question: how do we know how well our students are learning? Now, the traditional way to do this, how many of you are teachers and professors yourselves, right? So maybe in the past you've used these techniques to get a sense for how well your own students were learning, looking at their scores on some assessments, their performance on homework, comparing them to previous cohorts of students going through your courses. All of these issues are certainly helpful to us, but they are largely based on an intuitive judgment of how well students are learning that we then can use to understand not only how well students are doing, but what they're learning and how we, as their teachers, can help promote even better learning. There is a new way. That's why we're here today. And I'll just show one particular visualization there. The reason I have a question mark there is we are still at the beginning of this field. One could argue the Wild West of different approaches being used to understand how well students are learning. And so the question that I'm raising is how these analytics can give us even better or more full insight into students' learning. To start off, I thought it would be good to get a sense of how much our learning analytics can do to improve the current situation that learners are facing today. So this is a typical result. Students spend lots of time in their introductory courses and yet gain far too little for what they've put in. This happens to be a result that I found in some work in an introductory statistics course at Carnegie Mellon, but it's representative of the many studies that are coming out over the past decade or so on the lackluster improvements that these introductory courses often show. Now, many of you mentioned that you're already teaching, and so if I were in the stands, I might be looking at this result and say, sure, but that's that professor at Carnegie Mellon. Certainly in my courses, this is not the situation. Maybe that was a dry professor or someone using some traditional methods. Well, as it turns out, it was an award-winning lecturer in this case, and it was actually fairly forward-looking techniques of instruction. Very interactive lecture 3 times a week, plus a collaborative learning computer lab session 1 time per week. And yet still, as a result of that somewhat rich experience, students' learning gains were much smaller than we would want. So we can improve that. That's why we're all here today, I think. What I want to just put before you is a result that was another part of that study that actually we've replicated in several other situations. If the sort of baseline of a traditional college course is that students are spending more than 100 hours and having only about a 3% learning gain, what is the possible improvement that we can see effectively using educational technology and learning analytics? Well, in one of these studies that I conducted with my colleagues at Carnegie Mellon, we found that in the adaptive data-driven course, students were spending a lot less time. We actually had them work on the same introductory statistics course in a mini semester. That is 8 weeks instead of what we usually have, 15. And on the same measures of learning, one of them I've reported here, students showed 18% learning gain. So the question really is, what factored into that transition, and how can we do even better as we proceed in this field? In fact, in the conversation time after this large session, I can talk more about the details behind that study and others we've done since. So, of course, one possible factor in the arrow is learning analytics. So the question is learning analytics enough? Yes, I think that in part, learning analytics is a big part of this equation. But I think that it depends on how we carry out our learning analytics, how much we can actually lead to improvements in student learning. So one thing that is very powerful in this space is to develop predictive measures that can lead to action. And in many cases, these predictions can tell us about which students are going to run into trouble, what kind of performance students might expect on an upcoming exam. And prediction is very important and can be very useful. I would argue that on top of predictive approaches, it's also very important to think about the model that's underlying those predictions. And so if we approach learning analytics with a perspective in which we look to understand the underlying mechanisms, we can be even more targeted in the actions that we can recommend to students, that we can offer to teachers, and also that we can use to inform course designers and administrators. So there are many situations in which prediction is enough, when you just need to know what will the result be and get a good estimate of it. But in the case of learning analytics, I believe there is value for understanding and modeling in addition. For the purposes of cognitive science and learning sciences, we can use these large data sets to improve our understanding of the underlying scientific theories and mechanisms. But also, when we are looking to give recommendations to teachers and students, it can be helpful not only to tell them what's going wrong, but to give them some insights into the learning process of students that can help a teacher to go through some professional development and actually have a better understanding of his or her students' learning, as well for students to better understand their own learning. So a metaphor to capture this a little bit is that prediction might tell you that tomorrow you're going to have a fever. So that would be important information to know. But even better, if that information, that prediction, came along with a diagnosis of the reason that fever is going to hit you tomorrow, and potentially a few set of treatments that will help address those particular diagnoses. And in my work at Carnegie Mellon with professors working to improve their teaching and their students' learning, we often find that the surface features of the learning challenges can have multiple, quite distinct diagnoses. So really getting under the reason behind some learning difficulties can be very important. So in terms of pushing the learning analytics that we're doing to be as effective and efficient as possible, I'll argue that there are three key ingredients for thought. One is that these learning analytics are informed by cognitive theory. This is my own background, and I see a lot of ways we can merge these two worlds, as Dan was saying, and bring them together in a unified approach for learning analytics. I also have found that tying learning analytics to solid course design is very important, and as we all are looking to design these learner analytics in a way that best meet our users' needs. So I'll begin with the feature of informed by cognitive theory. So what we really want, as I said in the introduction, is to understand what students have learned. We want to understand their learning states. Each student, what's their profile of learning? And I argue that we can benefit from cognitive theory underlying that. In the sciences of learning, there are actually a lot of theoretical developments that give us some really good starting point for modeling these data. So some of the mechanisms that have been used in computational models of learning data are listed here. And we have a history of detailed cognitive models that successfully capture learning and performance, usually in the lab or working with cognitive tutors. I think we can use these same models when we're looking at the data collected and harvested from many of the online educational technologies today. And so I'll give you an example that focuses on just one of these mechanisms and incorporating it into a learning analytics system. The power law of learning. It's actually a very robust phenomenon going back many years in the field of cognitive psychology. And basically, if it looks a little bit like this, where practice is on the x-axis, the phenomenon is that as students practice in a given task, their performance improves, but that improvement follows a pattern of marginally decreasing returns. So you can see in the early practice, a specific amount of practice leads to great improvement. Here we're seeing errors reduced. Later on in practice, that same fixed amount of time practicing leads to a much smaller improvement. This phenomenon is very robust, and that makes it a powerful diagnostic as to how well students are learning. So I'm telling you, this phenomenon has been found in many different task domains and situations in real learning contexts, and yet you may be like me thinking that my students' data do not always look so nice and smooth. So what I'll show you next is a toy data set, just a very small data set, to exemplify how we can use the power law of learning as a diagnostic in understanding how well students are learning. So here is a set of 6 practice problems in introductory statistics. Again, I'll use that as the example. And you can see that the error rate is not at all smooth. A faculty member might think, wow, I gave my students 6 problems in this homework assignment. Why is their performance so bumpy, not showing the improvement we would expect? Well, one reason that it's very natural for instructors not to understand how students could be having such difficulty is that from their expertise in the field, they have aggregated information into much larger chunks, and they see general principles and skills that their students might not yet have learned. Indeed, these 6 practice problems that the instructor might think of as all of a piece, all exploratory data analysis problems, for students, they may actually be practicing very different skills. In the first 3 problems, students need to interpret a histogram. The next 2, students need to interpret a table. And let's say on the 6th problem, students need to interpret a box plot. So from students' perspective, there actually are 3 different skills being practiced across these 6 problems. This reorganization of the data, representation of the data, can help us see how the power law of learning is still actually in place. We can reaggregate the information so that instead of looking at practice overall on the x-axis, we can look at practice opportunities for a given skill and look at all of the cases where students are practicing a skill for the first time, put those together, and second time and third time. So I'll show an intermediate representation, and when we average this over the 3 skills, we have something that looks a lot more like the power law of learning. The approach that I'm using here, any of you who attended the workshop on learning curve analysis may recognize the kind of approach that I showed here. And so there are a lot of tools for doing this kind of analysis on more than toy problems if you go to learnlab.org. Indeed, what this analysis can do is not only work in a forward direction to help reorganize data sets, but can work in a backward direction, as it were, to help understand what are the separate skills that students are learning in a domain. So this kind of data analysis can help us better understand and parse a domain into its constituent skills. I should say that this approach, though, does not imply that one must give students practice at isolated skills. That was just a toy example. This analysis approach can be used when complex tasks actually are engaging multiple skills at a time, and the same kind of analogous analysis can be conducted. So really then, a more precise statement of the power law of learning is that as students practice a given skill, their performance at that skill improves, and other skills are not affected. If we think about using the data sets we have to understand students' learning of individual skills and use this power law function to estimate their strength of learning of each of those skills, then we have some really meaningful data that we can give back to instructors and students. If we focus on skills, if you're not paying attention to the skills students are trying to learn, then I argue you're missing something fundamental. What this means is that teachers can track students' learning skill by skill and adapt their teaching to meet students' needs. So instead of having to rework an entire lecture, a teacher could then focus on what are the particular skills or skill areas where students are having difficulty. This could be the skill of integration, or it could be a particular concept or misconception that's giving students difficulty. Similarly, this can help students monitor their own strengths and weaknesses and focus their practice where they need it most. So again, using this approach can allow us to target the work that students and teachers do where students need it. I think it's especially important for students because they may be not only novices in the field of study, but they may have rather weak metacognitive skills. That is, they may not be the most accurate in assessing their own strengths and weaknesses. So giving them this kind of information could be very useful to them. Another approach to consider in developing learning analytic systems is to build that system into a solid course design. And so I won't talk about this very much, but I will say that in terms of what we know from instruction and cognitive science and learning science, there are many aspects of how you design activities for instruction that make them more effective. I've listed just 3 here. One is that the activities that you have developed are aligned with the skills you want students to learn, that there are opportunities for repeated practice, and that you are providing targeted and timely feedback. One could also add to this list that the activities are engaging to students, are at the appropriate level of challenge, and that tie to students' interests, goals, and values. In doing that, thinking about the relationship between the course design and the data that will be collected, one can focus on questions that the data can actually help in analyzing how well was that course designed, what skills did not receive enough practice. And this kind of learning analytics can not only be useful then to students and teachers, but to the course designers and administrators. The third thing that I know we're all focused on is meeting users' needs. So looking at our learning analytics systems in terms of how they will be used and what the learner's constraints and other affordances are. Now, the two users I'll talk about most here are instructors and students. So instructors typically only have access to averages or distributions of student performance on graded activities. Our current situation then is one that instructors have rather coarse implications, and these kinds of results come too late without any kind of fancy learning analytics. What an instructor then really needs is a quick, up-to-date, actionable information. That is, results from the learning analytics that can guide the instructor's subsequent action to be more effective and more efficient. And some pieces of this that we found in our work with instructors is they're very busy, so they need a quick snapshot of how the class is doing. But if they see trouble, they want to be able to find out more. So also they need access to details on students' areas of strength and difficulty. And they may also benefit from getting some alerts to noteworthy patterns in student learning data. Also, some instructors, especially those who are new in teaching in their field, may benefit not only from finding out where the students are having difficulty, but getting pointers to opportunities or resources that could help them support and adapt their teaching to help students' learning. This is the kind of situation where the recommendation of the system could be for the instructor as well as to the student. Students' current situation is that they typically, sadly, only pay attention to the grade. In many cases, when students, especially early college students, receive some first college exam, they may have an emotional response and not have much reason or incentive to remediate. One of the reasons for that is by the time they're getting back an exam, the high-stakes feedback, the class has already moved on to the next topic or next unit. So not only would they perhaps have difficulty knowing what to do to resolve their misunderstandings, but they have no time to do it because the course has already moved on to the next topic. I think in this situation, students can really benefit as well from having up-to-date, actionable information. That is, information that can help them target their activities. So a quick snapshot of how the student is doing, access to the details and more insight into his or her strengths and weaknesses, and alerts to noteworthy patterns in that particular student's learning. For example, some of the things we've been experimenting with is looking for patterns in the time course of students' study, so that if we can identify students cramming before an exam versus spacing their practice at regular intervals, and indeed even relate those patterns to their behavior, we can give students an alert and let them know there are some other strategies they should consider. And finally, students, if they're getting this information in a timely manner, then it's all the more important to give them some access to resources so they can do something about it. But students also, like faculty, don't have a lot of time, so having a mapping from the difficulty areas to some instructional resources that past history shows can give students a lot of help in targeting those difficulty areas would be just what the students need to know. Kind of, if you were to spend 30 more minutes practicing on this, even 5 more minutes, here are the 2 things that you should consider practicing. Instructors and students both need these meaningful and actionable inferences from the data. And I think that a lot of the work that is most exciting to me at this point in learning analytics is focusing on the visualizations and how we can provide that information back to students and instructors in a way that can make the best meaning. So we want those visualizations to be quick to apprehend. I think this is where we can look for a lot of multidisciplinary collaborations to help us in this regard. We can also think about the visualizations being flexible so that we may have some novice users of our system, but hopefully if they keep coming back, they will also develop expertise in using the system. So having the flexibility for students to drill down and find out more, or for instructors to drill down and find out what was the kind of problem that was giving students difficulty, and what are some of the resources that I can find to help. Finally, I think that a lot of our users may have different needs. So even where there is a lot of common constraint and opportunity, we should also think about visualizations that are customizable to the individual's needs. So the project that I've been working on that aims to bring these 3 components together is called the Learning Dashboard. This is a cognitively informed learning analytics system that's main focus is to estimate students' learning state skill by skill. Here's a quick picture of it. I'll be showing you more. The main audiences to which we have developed this learning dashboard are instructors, students, course designers, and also administrators. And going back to the 3 themes that I mentioned, the learning dashboard is informed by cognitive theory in that the statistical models that are analyzing the data are embedding this skill-based power law learning. So the learning dashboard, I should say, is a system that is designed to be used when students are doing a lot of their learning in online educational environments, so that we can collect the clickstream, computer-mediated clickstream data coming automatically from their interactions. All of those clicks can be fed into a statistical model, and one of the things we have done already is to incorporate the power law of learning into that modeling effort. We also have built the learning dashboard into a framework or a system where the course design is a very important piece as well. So we focus on alignment, sufficient opportunities for practice, and feedback. One of the main platforms where we have implemented the learning dashboard is the Open Learning Initiative. You can find more about it at cmu.edu/OLI. And indeed, one of the key approaches that the OLI course design use is to make sure that the learning outcomes are mapped well to the instructional activities. And that kind of alignment is exactly what will support students to get enough practice and feedback on what they need to learn. The third piece of the learning dashboard, focus on meeting users' needs, is also true. So in terms of thinking about what instructors and students want to know, these estimates of students' learning state, skill by skill, we found can be very useful to instructors and students. But we also offer aggregated at-a-glance views so that there's an easy way to see right away how student learning is going. And we have refined and are continuing to refine our visualizations through user testing. So hopefully, with this approach, we can build on what most learning analytics systems are doing to really reveal what students did and did not learn, to quantify how well students have learned each skill, identify patterns, and even measure the effectiveness of particular instructional activities. So I've talked about the learning dashboard. Let me give you a feel for how it works, and then I will show you in slides a bit of a cartoon display, a storyboard of how it's used in practice. So as students do online instructional activity, their data, that clickstream data, are sent to the learning dashboard. Real-time analyses are performed to estimate students' learning. And then interactive visualizations and recommendations are produced to help students and teachers adapt their teaching and learning. So here's a student working on an instructional activity, drawing on whatever knowledge and skills he has already, making some answers that may be correct or incorrect. The question is that we want to know as his instructor, perhaps, or the student wants to know is, what is his learning state? So to answer that question, the interactions are transmitted to the learning dashboard, and there is inferences are being made about students' learning state, skill by skill, that are evolving as the student continues to work in the learning environment. This estimate of students' learning state can be sent back to the student. Here's a quick display showing the student's strengths and weaknesses, and each of those can communicate information to the student, helping him know where to go for more review or remediation on those areas of difficulty. It's also the case that there is a view for instructors to see their class as a whole, how is it performing, and to drill down and get more information. In terms of the modeling behind this, we have a Bayesian hierarchical modeling approach to capture the multiple components of variation in the data and to make sharp inferences. As I've said, the main variable we're interested in is students' learning state. This can become more accurate as the data accrues. We also, due to the hierarchical approach, can borrow strength across students, classes, and populations to improve the precision and generalizability of these results. And of course, because of the size of the data sets, we need to think about the algorithms and computational methods behind it. In terms of interoperability, there are a few points to mention. One is that the system has a RESTful API that makes it easy to interoperate with different learning environments. So as long as that learning environment is instrumented to send messages to the learning dashboard, we can work with it. That instrumentation is fairly simple and is supported. And by this approach, we can scale to large numbers of students. What I think is also nice about the API is that we have mechanisms for the community of users to share their information. So as I'll talk about next, one of the key aspects of this approach is to think about, for each instructional activity in the learning environment, what is the skill or set of skills that are being exercised or supported by that activity. As different users work on submitting their data to the learning dashboard, they can borrow from each other's work in understanding how these instructional activities support students' skills. And that leads me to the idea of domain generality. So what we try to do is we have not only technical interoperability, but semantic interoperability, in that we can handle data from a wide variety of tasks and topics. And we do that by a tool called the skill map, is what we call it. Again, this relates a lot to the Learn Lab approach. And this skill map, in our case, is something that connects each instructional activity where a student would have a response, an interactive response with the learning system, to the skills in the domain. So it's basically a mapping from each interactive element in the learning environment to this one or more skills in the domain. Having that mapping can be used both ways. One that I've focused on is that then we can analyze the data and aggregate it skill by skill to get these estimates. It's also the case that the skill map can be used for recommendations. So if you think about it, going from the instructional activity to the skill, then if you find a student has difficulty in a particular skill area, we use that mapping to give recommendations as to which activities would be the best for supporting practice in that skill. And we have some tools, we're working on more, to facilitate this skill mapping process. At this point, I wanted to go to show you a quick demo in the few minutes we have left. So here's a view of the current learning dashboard environment. As you can see, it's blank. I've set it up with a blank canvas so that I can show you how the user can add different views. Imagine that you are the instructor of an English language arts class. I believe that's how I've set it up. And you have about 20 students in your class. You've given them an assignment to finish a particular set of the online materials, and tomorrow you have class with them. So here you're going to take a look at students' data. How we've organized this is in terms of the questions that our users, in this case instructors, might be asking on what skills are my students struggling, how's my class doing, etc. So we'll go to the first one. See a little bit of this. Here we can see a snapshot of, the default here is to show the 5 skills that our students are showing the most difficulty on. For each of those 5 skills, you can see there are about 20-some individual blocks. Each block represents a student's learning state on that skill. And in terms of a kind of heat map approach, this can give the instructor for these 5 most difficult skills how students are doing. The user can look at individual skills and drill down. So if you click on that, I think this one is finding stasis in a text. The other skills that were showing difficulty were identifying a claim and analyzing an argument. I just chose to drill down on this one in this demo. Oh no, I'm looking at a blow up. Here we go. So here you can see individual students and how they're doing. If you click there, you can see the individual students' learning state on that particular skill. And then I think I dismissed this to go back up to the high level to show you a few more things. One thing that is worth noting here, I think, is you see there are a few gray cells as well as the colored cells. So red is an indicator that students' learning state is low, and green is an indicator that their learning state is high. In some cases, because students have not interacted with the system very well, even though we have an estimate of their learning state, the uncertainty around that estimate is very high. And so one of the things we're thinking about is how to communicate that degree of uncertainty to users. So we just put those as gray for now. Another thing to note is that you can edit each display. In this case, if you were editing the view, or you could download it here, you could edit it to have more than 5 or fewer than 5 as the default. Next, I looked at the misconceptions graph. I picked a data set where there are a lot of misconceptions. We can also track this in terms of essentially how much does it look like students have learned the bad habit? How strong is their practice at these misconceptions? I think the next thing is an instructor might want to know is given that my students are having difficulty in a lot of these areas, the misconceptions are not looking too bad, and there's nothing that really stands out. So the instructor might want to see, well, given this, where have my students practiced the least? Maybe the reason that they have done poorly is because they haven't been practicing very much. Well, if you think about it, there are a lot of different metrics for practice. What we have here is one that is in terms of the opportunities to interact with the material on a skill-by-skill basis. So this practice is represented in terms of skills, and you can see when I go in that identifying the claim has gotten very little practice by students. Also, analyzing argument has gotten rather little practice. I think I'll just let this play off a little bit to get to the next part. And from students' point of view, they might not be thinking of it in terms of skill-by-skill practice, but how much time or how many activities they've completed. So this is a effort-based measure. And then I also wanted to show that in this display, you can look at how much practice has been offered for each skill. So here it's interesting to see excuse me, that finding stasis in the text is actually getting the least practice, and so this may be an indicator that more activities on that skill would be helpful. And finally, I just wanted to show that users can move things around and indeed set up this as the next view for when they return to the learning dashboard. Excuse me. So I think, given time, I will talk a little bit about how that can be used for students. The same kind of displays, but focused on that student's interaction with a much more simple visualizations and simple display. Actually, I can show one or two of these if there's time. Here. So here we have this in the larger context of the network of skills students are learning. The key thing to look at is that students are just getting the 3 bits of information at the top, the skills they've mastered, the skills they need practice on, and any kind of metacognitive tips would be on the right-hand side. If the student wants to drill down on any one of those, he can. I think I was looking at what is more tips on the alerts for that student. In terms of take-home points, focusing on student learning, not just behavior, is the key to extracting the meaning behind the data, and this has been our focus. Incorporating fundamental cognitive mechanisms can make our learning analytics more powerful. User-centered design and solid course design are also an important piece of this, and the learning dashboard is something that we have found in our studies contributes to significant improvements in teaching and learning. And I can talk more about that in the second session. And there's our URL. I did want to conclude, oh, my thank you slide is not there, by thanking some of my colleagues. The collaborators in this work are Christopher Genovese and Judy Brooks and Carl Skipper, and also many of my colleagues at the Pittsburgh Science of Learning Center and the Open Learning Initiative. So with that, I'll end. Thank you very much.
So maybe we can take 5 minutes for questions now, and then after the break there's a full hour with more personal interaction with Marsha. Any questions for the audience from the other side?
Christopher Brooks from the University of Saskatchewan. So one of the Achilles heels of intelligent tutoring systems or adaptive systems is how much of this domain you have to map early on. So all these knowledge components you have to create. One of the things learning analytics has been good at is reducing this mapping by just visualizing whatever data so far we can find. Do you think that this approach is really scalable across full institutions, or will it just be implemented for specific disciplines, specific courses, mathematics courses where a lot of the ITSs are from? Could you just maybe comment
Yes,
on that?
yes, that's a great question. And I do think that there is a tension between using the big data, just mining what we can from it, and building in some conceptual framework into that process. What I'm trying to find is a sweet spot, kind of a happy medium. So two things that are relevant to your question. Number one, there are now more automated or semi-automated ways of doing that skill mapping. So I don't know if John talked about those in his tutorial, but one of the things that we are able to do is use those automated methods to take in the data and generate a pretty good skill map by doing the sort of reverse process of looking for those power law learning curves. The other thing that then our learning dashboard does is to take that, that requires some archival data. And so during the course of the semester to use the ongoing student interaction with these interactive elements to identify places where the skill map might be not so good. So what we're trying to do is a sort of bootstrap process where we use the data to get a good start and then refine as we go. The other thing I was going to say about that is that I think as we move forward, there will be some cases where if there's a given domain, say introductory statistics or some mathematical field, maybe some of these gateway courses where some domain focus is really going to be able to be an investment for many, many students, that we may see that there are discipline-based researchers and analysis folks and learning science folks who can come together. And this is another bit of the sharing that I think would be very useful. If we have the skill maps in a format that they can be, the skill sets, that they can be easily then interoperated with other new activities as they come online, that will be helpful. My hope is that the pressure, in some sense I'm trying to turn the assessment pressure we all feel into more of a positive forcing function, that if those learning outcomes and standards are things that also could feed into having some standard language for this, it would be very helpful. So I'm trying to stay in the middle. It's a good question.
And there's a person in the back.
Marsha, thank you for a good talk. I want to be a bit provocative. And also question this, is there a fundamental assessment regime assumption in what you presented? Because it's more or less, for lack of better term, quote unquote, the Anglo-Saxon model of assessment, which is the dominant one, but it's not the one in my part of the world. By the way, my name is Ravi Vatrapu. I'm at the Copenhagen Business School. So in the Nordic countries, it's not the, we don't have this kind of assessment format, right? So is this, to what extent is this really portable, or is it across assessment regimes? That's basically my question.
So I think that there is, in all of our work, there are theoretical perspectives and philosophies that frame our work. And it's certainly the case that I'm looking at this from the point of view where we are looking for learning gains and using methodologies where pre-post measures focused on the learning outcomes of a given course. And so I think that that is indeed the focus or the framework that I am bringing to it. I would be curious to see and think more about the question of how some of these methods, I mean, basically the underlying idea that I think is more central to me is that the modeling of the process is really the key. So while the implementation and the framing that I bring to it is definitely in this assessment one assessment regime. I think that the more translatable theme is to think about what are the key underlying processes and how can I build into my modeling or incorporate into my data mining some of the research from the cognate fields to bring more structure to that data analysis. So that underlying theme, I think, has much more generalizability, and I would be delighted to think with people about that prospect. Thank you.
Do you think that the models that you have of do you think that the models that you have of the clickstream data are ever likely to become powerful enough that you could forego the achievement test and simply know the state of the learner accurately enough?
I think that reality is already coming to pass. There's one set of work in Massachusetts state testing, and shoot, I'm trying to think of the name of my former colleague who's doing it. Where the project is called Assessments, and you get the pun. It's assessment and assessment. And the idea is that if you're doing this ongoing collection of the clickstream data in the context of real problems, and if you've analyzed those in a way that can map to the learning outcomes similarly that are tested on the assessments, the high-stakes assessments, and if you can show that your predictive validity is strong enough, then why have students spend a day where they're not learning and just going through these high-stakes assessments? So I think that there is definitely that possibility, and I can point you to some work in that direction. I think it would be very nice if we could move in that way.
Okay, so I think we'll wrap up here. As I mentioned, after the break, there's another session with questions for Marsha. Thank you very much, Marsha. That was a very excellent question.
Okay, we have a couple of loose ends to take care of. Eric, I've got to plug this thing in.